Hello dear students, welcome to BYJU'S Exam Prep. So guys, here is your next lecture for the capsule course in which we will discuss the various type of 2D support which we are using in our structure part. As well as you can say that in your different subject you are using these type of support already. So let me tell you guys, basically in engineering mechanics part you are using the truss analysis. So in that case you have to use this particular 2D supports. If you are learning the strength of material, so definitely you are learning the determinate structure in which you again use the 2D supports. And if you are learning the structure analysis, so definitely guys, in the structure analysis, whether you have determinate structure or indeterminate structure, in both the cases you need to 2D support, and so that you can analyze the structure as well as you can design the structure. So guys, no doubt these type of supports are very important to understand, and at this particular lecture you are able to understand how many reactions is to be developed at the various type of 2D support which we have. Okay, so let me introduce myself also so that we can move further. So my name is Krishna Yadav guys, and I'm teaching from last 9+ year, and I have done my masters from IIT Roorkee. I'm entered almost 20,000 plus students for various examination. And generally these are the subjects in which I deal, like your environmental engineering, structure analysis, RCC and engineering mechanics. Let me give you one more information which is very useful for you guys. There is one GATE scholarship test which is on 12th of June at 11 AM. So you can give this particular test and kindly register it so that you can get some scholarship for GATE preparation program. Now guys, let's understand what are the different type of support which we have and which we have to use in our different type of civil engineering subjects. So guys, this is the first type of support which we are using. Let us suppose there is one cable which is to be attached over some surface, right? Or either you have a link. What is basically link? Let me tell you about it. So guys, it is a member which can take only axial force, and it is connected with 2 pins, or you can say that it is connected with 2 hinges. So this is known as what? This is known as link. It can carry only axial force, right? Now what happened guys, we know that if it is a cable, then this particular cable, let us suppose this is a cable, okay? So if it is a cable and it is attached to some surface, so what will happen? This cable is to be designed to take the tension force only, not the compression one. So if I give a tension force like this, so as per Newton's third law, we can say that every action has equal and opposite reaction. So if you are giving some force in this direction, so definitely a reaction is to be developed in the backward direction. So we can say that at this particular contact surface where the cable is attached, a reaction is developed but opposite to the direction of this force, right? In the same manner you can understand in case of link also. So you can see here guys, link is designed to take the axial force only, so it can give only a one reaction at that particular support. Clear? So you can see here guys how we can represent this particular type of support. So this is basically our idealized symbol by which we can represent either you have a cable or either you have a link over a fixed surface, right? So you can see here guys, this is our symbol which we can use generally. Now how many reactions to be developed at this particular connection, or you can say that the support? So we can say that only a single reaction is to be there. But if I represent it, so guys, you can see here for the cable condition, you know that we are trying to give the tension force in the cable, so definitely a opposite reaction is to be developed in the backward direction. So you can see here guys, a reaction is to be developed at the support which is to be like this. Clear? So this is the one of the, you can say that the support which we are using in our structure part. Now let's understand the another type of support which we have. One is roller and second one is rocker. No doubt both the type of support are taking only a single reaction, but we can say that guys, they are truly different, right? They are truly different. Now let me introduce it so that you can understand. So you can see here guys, this is a roller support which is to be represented like this. If you have a simple triangle and below that you have some wheels which is roll over a surface. So this is basically a roller support, or either you can represent it by putting a circle in between 2 portions, right? So you can see here guys, this is another type of roller. Now what is the idealized symbol which we can use? For this particular thing you need to draw a triangle and make a 2 wheels at the bottom. So this is your idealized symbol for the roller support. and either you can draw this one also guys by making a circle and place a member which is a you can say that a line member, right? Because generally we are trying to analyze a structure which is known as skeleton structure. What is skeleton structure? It is nothing as it is a line diagram. So this is basically a line member, you can say that. So this is a circle which is in between this member and this particular surface, which is nothing as our roller support. Now it can take only a single reaction, which is a vertical one in this particular case. You can see here guys, we have a vertical reaction like this. Clear? Now what is the difference between roller and rocker, and how many reaction rocker will take? That is another point, right? So rocker is nothing as guys, basically it is the support which can take another one reaction only, but it have only limited horizontal displacement. That is the major thing, right? Now you can see here guys, this roller can move in this particular direction or in this particular direction, and it can move along to the horizontal direction as per the expansion or contraction of the member, right? Now it can have you can say that unlimited space to move in the horizontal direction. But in case of rocker support, what will happen? Let me show you that so that you can understand. I think all of you have seen some rocker chair is available in the market generally. Let me show you that also so that you can understand it. This is basically a rocker chair. Like this, right? Now if you tilt it little bit, so what will happen? You may have a little bit horizontal displacement, or you can say that there is a limitation in case of horizontal displacement. Now this chair can tilt in this particular direction also and in this particular direction also, but it can come back to the original position, right? It will come back to the original position again. So it is to be like this, right? So in this case you have a limited horizontal displacement. That's why it is known as rocker support. Now you can represent this rocker support like this, or either you can represent it in this manner also. Let me show you that. You can draw a triangle and put a curved surface at the bottom, and which is placed at a horizontal surface like this. So you can make rocker support in this manner also. Now again guys, in this particular case you may find only a single reaction, which is nothing as a vertical reaction like this. Clear? So rocker and roller will have only a single reaction, which is generally vertical reaction in this case. Now guys, let's understand the another type of support which we have, which is a member, and it is to be placed over a smooth surface. Now let us suppose guys, this is a smooth surface, and let us consider this is the free end of a member, and if I place it on this particular surface like this, correct? Now what will happen? We know that guys, this surface is a smooth surface. It don't have any kind of friction. So definitely it will produce only a single reaction, right? So let me show you that, which is basically a vertical one. So you can see here guys, this is a smooth contacting surface in which the friction is equal to how much? It is 0. And this is the member which is placed over it. So how you can represent this? As I told you earlier also guys, we are using skeleton structures. And generally we are representing the members by a line, right? We are not showing any kind of thickness of the member in our structure analysis or in our analysis part, right? So in this case also you can see here guys, this is our member which is placed over a smooth surface which don't have any kind of friction. So definitely it will have only a one vertical reaction, which is to be like this, right? So this is the vertical reaction which is developed at this particular support. Clear? Okay. The next type of support which we have, which is known as smooth pin connected collar. Now what it is exactly, sir? Let me show you. Let us suppose this is a rod over which if I place a collar which is to be like this, and just consider guys, through this particular collar if I connect a member which have a connection of pin over here, right? So we can say that the collar and the member, the angle between them can be changed while moving this particular collar in the horizontal direction. So you can see here guys, this is a pin which is connected with the collar and the member, and the angle between the horizontal surface, or you can say that with the horizontal this particular angle can be changed. If you move this particular collar in this direction, definitely this angle will change. And if you move this particular collar, definitely again the angle will also change, right? Now how we can represent it? Guys, it is very simple. The same type of figure you have to draw, but you need to draw this particular member as a line or as a line member like this. And again, you need to draw a pin. Clear? Now the question is, how many reaction can develop over here? Now you can see here guys, this particular collar can move in the horizontal direction easily. So definitely it will not produce any kind of horizontal reaction. But if we try to pull this particular collar, right, if you try to pull this particular collar, then what will happen? A vertical reaction is definitely developed at the junction. So you can see here guys, a vertical reaction is to be there. What about movement, sir? Guys, in this particular case, there is no movement reaction which is to be developed over here, right? Why? Because the angle between this particular member and the collar can change while moving it. So definitely we don't have any kind of reaction which is an angular reaction. Clear? So this is the one of the type of support, you can say that guys, in which again we have one reaction. Now let's understand the next one, which is known as smooth pin or hinge support. Clear? Smooth pin or hinge support, or you can say that pin support also. So basically this particular support will have two reactions. Why it have two reaction? Let me show you that guys. It is to be fixed at the base, so this particular portion of the support cannot move in the horizontal direction and it cannot move in the vertical direction also. But what happened guys, the member and this particular support has a pin connected over here, or you can say that a hinge is there. So what will happen, the angle between these two parts, or you can say that the angle with respect to horizontal can change, right? So definitely the angular reaction will not develop at this particular point. So due to that reason guys, we have only two reaction. One is vertical and second is horizontal. Now how you can represent it? Very simple guys. Either you can draw a triangle which is to be placed on a horizontal surface like this, or it may be possible some vertical surface also, but most of the time you may find this particular support is to be placed on a horizontal surface. If it is vertical, let me show you that it is to be like this. Clear? Now in this particular case also you have two reaction, right? Now you can see here guys, we have two reaction. One is vertical, which you can write Fy, and second is horizontal, which you can write Fx. And again in this case the angle will change, so definitely there will not be any kind of reaction which is angular one. Okay, so we have two unknown in this particular case. Now let me show you one another type of symbol which you can use in case of pin support. So guys, you can draw in this manner also. Let me show you that. You can make a surface with a hash line and try to draw the pin support like this, right? And your member is to be like this. Clear? So this is again guys your pin support. You can represent it in this manner also. Now the next type of support which we have, which is known as fixed collar support and a slider, or you can say that the guided roller support also. So let me explain the guided roller as well as the fixed collar support. So first we will try to understand the fixed collar one, then we'll come back to the slider or the guided roller. Okay, now you can see here guys, this is a fixed collar support. Now what is fixed collar support? Basically in this particular case the member and the collar is to be fixed together, or you can say that the angle between the member and the collar is not to be changing, right? Due to that reason it is known as fixed collar support. So the angle between the collar and the member is 90 degree always. So this angle will not change. If it is not changing, so definitely it will have two reaction in. One is angular and second is you can say that in this case as a horizontal reaction for this type of fixed collar support. You can see here guys, you are not able to pull this particular or pull out this particular collar from this particular rod easily, right? So definitely we will have one reaction which is to be like this, and the second one which is basically a movement reaction which is to be like this. So due to that reason guys, we can say that we have two reaction in case of fixed connected collar or fixed collar support. Now if we talk about the slider, which is also known as guided roller support. Guided roller support. Guided roller support. Now basically guys, we have two type of guided roller support. Let me introduce it. So there are two type of guided roller support. One is vertical guided roller support. Vertical guided roller support. And the another one is horizontal guided roller support. Horizontal guided roller support, or you can say that vertical slider and horizontal slider. Now the question is, sir, what do you mean by it and how we can understand it? That is another part. So guys, I think all of you know that what do you mean by guide? Guide means to give some direction. So if you have vertical guided roller support, that means you are trying to allow the movement of that particular support in the vertical direction, right? We are not restraining it in the vertical direction. And if we talk about the horizontal guided roller support, that means we are allowing the horizontal displacement, or we are allowing the movement of that particular support in the horizontal direction. We are not restraining it. So that's why it is known as horizontal guided roller support. Now the question is, sir, how it look like? Let me show you that. So guys, if we talk about the vertical guided roller support, it is to be like this. You can make a box which is connected with the rollers, and it is to be placed between two surfaces. Now you can see here guys, this particular support is a vertical guided roller support. Why? Because the movement of this particular roller is to be allowed in the vertical direction. Now you can see here guys, we have two reaction in this particular case. One is horizontal and the second one is moment reaction. Why? Because this member is to be connected with this particular box and it is to be welded. You can see that guys, and the angle is not changing, which is generally 90 degrees. The angle will not change. Due to that reason, you have two reaction over here. In the same manner guys, we have horizontal guided roller support. Now in this case, we are just allowing this particular movement of that roller in the horizontal direction, right? So this is the difference between the vertical one and the horizontal one. Let me show you that figure also. So you can see here guys, this is the box which is connected with the roller, and you can place it in between two surfaces, and this is the member which is connected with this particular box, and the angle between them is 90 degree again. Now again guys, we have two reaction, one is vertical and second is movement. Clear? So these are two reaction only guys, which is developed at the horizontal guided roller support. Now I think you are able to understand easily. Now how you can represent this particular guided roller support or slider? So you can see here guys, the idealized symbol is to be like this. You have a wheels in between these two surfaces, and the member is to be connected with this particular portion, and it is making an angle of 90 degree, which will not change. Now guys, as I told you earlier, either if you have fixed collar support, or either you have vertical guided roller support, or if you have horizontal guided roller support, you have only two reactions, right? But you can understand guys, the placement of reaction will get changed if you have vertical and if you have the horizontal. The placement of the reaction is little bit different. As you can see here guys, in this case we have horizontal reaction, and in this case we have a vertical reaction, right? So these are the two different type of support. One is fixed collar and the second one is slider. Now the last type of support which we are using mostly in our structure part as well as in our indeterminate structure, mostly you are able to see this particular type of support in indeterminate structure guys. That is basically fixed support, which have three reaction at this particular point. So you can see here guys, the fixed support is to be look like this. If you have a member which is connected with a surface and the angle is not changing, the angle is 90 degree itself. So you can see here guys, you need to draw a line and put the hash line, and it is to be connected with a member, and the angle is not changing. This angle is 90 degree only. So guys, this is the idealized symbol which we are using over here. Now you have three reaction. One is Fx, second is Fy, and third one is Mz. So basically all three reaction is to be developed at pixel. So these are the support which is mainly used in our structure part, or you can say that in your strength of material, engineering mechanics, as well as the RCC. Why? Because mostly we are trying to analyze as well as the design the 2D structure, right? So due to that reason, guys, you need to understand all the different type of support you are using in case of these structures, right? So I hope you are able to understand the whole concept of various type of 2D support. And in the next session, guys, definitely we will bring some more conceptual part which is to be useful for your examination, right? So thank you so much for joining the session, and please subscribe our channel, and please hit the like button as well as hit the bell icon also, so that you can get the notification for upcoming class. Thank you so much. Bye bye, guys.